All right, let's try our hand at this polar graph. R equals 5 over 15 minus 10 sine of theta. Well, I can already tell this is not going to be a fun problem. So please notice that you have a common factor for all of these terms. And let's reduce all of these guys by that common factor. So that becomes 1 over 3 minus 2 times the sine of theta. Okay, but we still want to have this guy right here to be just a 1. That way it fits into the correct form. Okay, so we'll get to that in just a moment. Because we have the sine right there, we know that the directrix will be parallel to the polar axis. But I don't really know much of anything else yet until we find E. All right, so if I do some slight rewriting here, I guess I just need to divide everything by 3. So I'm going to erase this guy. All right, so in order for me to get a 1 down here, I need to have this as a 1/3 to multiply on the top and the bottom. So this gives me 1/3. I know it's kind of messy, but just trust me on this. 1/3 of 3 is 1, and then minus 2/3 times sine of theta. All right, so in this form, we can identify that our eccentricity is 2/3. And since this is a value that is less than 1, that means that we are dealing with an ellipse. And what's that p-value? Well, remember that this is supposed to be E times P. So we have to do a little bit of work. Not a whole lot, but I mean, we'll be able to tackle this without a problem, I think. So that means that E times P is 1/3 and E is 2/3. All right, so to get P by itself, I got to multiply times that reciprocal, which is 3/2. That reduces, oh, that's actually not too bad. That means the p-value is 1/2. Okay, so we have our E, we have the p-value. We know that our directrix is going to be parallel to the polar axis, and that also means that it's going to be perpendicular to the major axis of the ellipse. So keep all that in mind as we start to piece everything together. All right, and since this has a negative, our directrix is going to be below the polar axis. All right, so let's just try to draw something out and see what we can do. Since we're dealing with fractions, that may not be the most fun thing that we've ever done, but we can still take care of this. All right, so we have one of the foci for our ellipse is going to be at the pole. My directrix is supposed to be below by 1/2. So here's what I want to do. Let's make this to be a 1, and then our directrix is going to be down 1/2 right there. It's a little bit easier than trying to put it, halfway between one of those hash marks. All right. Now, since we're dealing with sine, the key values that we want to plug in will be pi/2 and 3pi/2. So let's try to complete that. If I have pi/2 for my theta, and if I have 3pi/2. All right. So I think it would be best if you kind of plug that stuff in right here. That way you don't have fractions and you don't have really big numbers for those other options. If I plug in pi/2, so sine of pi/2 is 1. So this is going to be 1 over 3 minus 2, so 1 over 1 is just 1. And if I make this 3pi/2, that makes it -1. And we end up with 1 over 3 plus 2, so it's going to be 1/5. All right. So when I'm at pi/2, which is facing up, I'm going to have a key point here at a value of 1. So I have this point right there. And then when I'm facing down at 3 pi over 2, I have another key point, and that's going to be at 1/5. Okay, that is not the prettiest thing I've ever seen. So we have 0, 1 in terms of the rectangular points. And then this guy is going to be 0, 1/5. And those should be the points for our, the endpoints for the major axis, right? Because we said that the major axis is going to be perpendicular to the directrix when we're talking about an ellipse. Okay, so that means the distance between the focus and this point is 1/5, which means the distance between this point right here and this other focus is also going to be 1/5. So that means that my second focus is going to be the ordered pair 0, 4/5. Okay. Well, what about the center? Well, the center, wait a minute. Why don't you guys see something? This should be a negative 1/5. My bad. So the center should be the halfway mark between really 1 and negative 1/5. So you think about the total change between these guys. Well, you know what? Let's not worry about that. That just means you need to do 1 plus negative 1/5 and divide by 2. All right, so that's going to give me 4 over 5 all divided by 2, which gives me 2/5. So that tells me that my center will be the ordered pair 0, 2/5. Okay, so not the prettiest thing that we've come across, but it's still going to work out okay. So our equation for this ellipse, we're going to have to do some more work on that. So it's going to be x squared over whatever the a value is, plus, now the y value is a little bit messy because of the fractions, so that's going to be y minus 2/5 squared over something, and that's going to equal 1. Okay, so we know the center, and we know the distance from the center to one of the foci is going to be 2/5, right? Because we have the center right here is 0, 2/5, and to go from there to the focus is 2/5. We're stretching the y direction, and so that means that we would have our a value is 2/5 squared. What about the x value? Okay, well, we're going to do a little bit of work on that, but I think we can manage. So our c squared, in this case, is going to be the larger values. That's going to be 2/5 squared minus the a squared we need to find. And we know c, because that's going to be the distance from, oh, nope, I have that backwards. Oh dear, I gotta slow down here. I knew something didn't seem right. Sorry, the distance from not the center to the focus, but the center to the endpoint is going to be 3/5. And so that's the value that goes down here. That's my a value. My c value is the 2/5. Maybe I've just had a long day. So c squared is going to be the b squared minus a squared. So that's going to be, c is 2/5. B is 3/5. So now let's just find a. So by rearranging some terms, we'll find out that a squared is equal to 9/25 minus 4/25. So that's 5 over 25. And that means that my a value is, we can say 1/5 for the sake of simplicity right now, but my a value would be the square root of 5 over 5. So underneath here, we're just going to say 1/5. Now, we can do some simplifying here, make things look a little bit nicer. So in terms of how this would look for the form for an ellipse, you would write this as 5x squared. And this guy right here, which becomes 9 over 25, puts the 25 in the numerator. And keeps the 9 in the denominator, and this is equal to 1. So, yeah, it's a little bit on the messy side, but that's all right. And then if we were to finish graphing this guy, it's just going to be an ellipse, nothing that's too incredibly powerful. And if we were to go to the graphing calculator to check our work, so we got this in dot mode, so I will say that the way that you set up dot mode here is different than it is in the calculators I'm used to, which is why in the previous video it just kind of threw me off a little bit. All right, let's see, okay, so 5 divided by the quantity, 15 minus 10 sine of theta. It's really hard to see. So we're going to change our window. X-min, let's make this -2 to 2. And the Y-min, let's make it -3 to 3. Yeah, so maybe I can square this up. Yeah, so there we go. So squaring it up so that we have the same pixels for the X and the Y direction, you can see that's very very similar to the graph that I have. Okay. Yeah. So there we go. All right, let's take a break and let's do some more.